Good morning to all. I thank KSOS and Dr. Samyukta for this opportunity. My topic of presentation is overview of binocular single vision, and I wish to present this topic under the following headings. It's very interesting to think why we need two eyes in the place of one and what unique advantage does it provide. Binocular single vision is considered to be one of the hallmarks of human race which enable it to have supremacy in the hierarchy of animal kingdom. So vision actually started as single light sensing receptors which evolved into a complex structure of eyeball. As a result of multiple mutations, different species got eyes that serve their unique needs. So a rabbit has a laterally placed eyes, a large binocular field of vision so that they can detect and escape from the predators. Look at the eagle, which has frontally placed eyes, then a large binocular single vision with stereopsis and better visual acuity so they can track and catch the rabbit. So man and primates chose binocular single vision for its advantages of stereopsis, better visual acuity, color vision and contrast sensitivity. This is the classic definition of binocular single vision by Romano and Romano, but a simpler version will be binocular single vision is a type of vision which enables us to fuse slightly dissimilar images from two eyes and perceive it as a single three-dimensional image. BSV is not present at birth and the adult values are obtained by 6 years of age. And we know that we need clear media in the eyes, accurate coordination between two eyes in all cases, and the ability of the brain to fuse these dissimilar images. So before we go into the discussion of binocular single vision, let us understand what are the characteristics of visual stimuli reaching the eye. It has these properties of brightness, form, color, and direction. So what is this direction? If I am looking at an object in front of me, that object will be stimulating a particular point in the retina of both of my eyes. And it goes on to say that when that particular point in the retina is always stimulated, it will be projecting in a particular direction in front of me in the physical space. To understand that, you can press the lateral eyeball at the lateral canthus, then you will see a scotoma in the nasal region, telling you that the visual direction of the temporal element is directed towards the nasal side. So there is a principal visual direction where the fovea is directed and secondary visual direction where the corresponding points are projected. So what are these corresponding points? They are retinal elements of two eyes that share a common subjective visual direction. For example, the fovea of the both eyes are considered to be corresponding points. When they are stimulated, they have a common visual direction and they meet at the point of fixation. Similarly, the temporal elements of the retina correspond with the nasal point and vice versa. There are millions and millions of corresponding points in that. So what is this horopter? Horopter is otherwise called horizon of vision, and it is the locus of all points that are imaged in the corresponding retinal elements for a given distance. So it will seem that objects of the point of horopter will be seen as double. But that's not what is happening. There is an area that is in front and behind the horopter where single vision is possible. And you can see that if objects are seen beyond or behind, there will be diplopia. It can be crossed or uncrossed. So now we understand that the slightly different images falling at the corresponding points of the two eyes are fused into a single image by the property of fusion, which is a motor and a sensory component. Fusion takes place in the brain. It is precise and it's happening all the time. It's a much underrated facility. And the bottom picture tells you what happens if you don't have a perfect fusion. Then there are factors which will be affecting sensory fusion and motor fusion. Unequal images like refractive error, unclear images like cataract can affect sensory fusion. But motor fusion can be much easily affected by misalignment between eyes and non-strabismic binocular abnormalities, which are the topic of discussion today. Now, briefly moving on to the traits of binocular single vision. If you can see two dissimilar objects simultaneously, it is called simultaneous perception. If you can superimpose two incomplete images and form a single one, it is called fusion. And now stereopsis is the most superior facility of binocular single vision, where horizontally disparate points in the Panem's fusion area are fused, and now you get a depth perception. So we should understand what's the difference between fusion and stereopsis. I think most important will be fusion can occur without stereopsis, but stereopsis is dependent on fusion. And fusion occurs or can occur for both vertical and horizontal corresponding points, while stereopsis is only for the horizontal disparate points. So now, for the completion of sake, I am mentioning the anomalies of binocular single vision. The non-strabismic anomalies will be dealt with in the next session by Dr. Mallika. So we know that diplopia, where one fovea and extrafoveal point is stimulated. Then confusion, here fovea of both eyes are stimulated by different objects. You get an overlap picture. Then there is rivalry, binocular retinal rivalry, that is simultaneous excitation of the corresponding areas by the dissimilar stimuli. This is what you get in binocular rivalry. Then finally, suppression, that is occurs in the immature visual system, where to eliminate diplopia and confusion, which leads on to amblyopia. So I am concluding my talk by saying that binocular single vision anomalies should be detected as early as possible because they can be reversed in the plastic period of development, and we need to have a better understanding and mechanisms of binocular single vision for optimal treatment. Thank you.
Thank you, madam, for that excellent